Hello dear students. In this video we are going to discuss about a very important concept called Coulomb's law. So what is Coulomb's law? Coulomb's law is very important law to describe the force between the charged bodies. We know that we have two charges, positive charge and negative charge. When we have two unlike charges, there will be a repulsive force or attractive force. Definitely it will be a attractive force. So positive charge will be attracted by negative and negative charge will be attracted by positive. Therefore, there will be a attractive force in nature. Whereas when we have two like charges, say two positive charges or two negative charges, when we have like charges, surely there will be a repulsive force. Both positive charges will repel each other as well as both negative charges will repel each other. This we have already seen. With what force? What is the quantity of the force with which the charged bodies or the charged particles will execute the force? That means the magnitude of the force and also the direction. So the law states that the force of attraction or force of repulsion doesn't matter whether it is positive charge or negative charge. In the case of two like charges, there will be a repulsive force. In the case of two unlike charges, there will be an attractive force. So generally we can say that the force of attraction or repulsion is directly proportional to the product of the two charges. Magnitude we are considering here, magnitude of product of the two charges, and inversely proportional to square of distance between the two charges. When we have two charges, say Q1 and Q2 here, they are separated by a distance, say for example R distance or D distance. When they are like charges, there will be a repulsive force here. There are two equal and opposite forces which are repulsive, and this force is expressed in magnitude by F proportional to modulus of Q1 Q2, F proportional to 1 by R square, or inversely proportional to square of distance. Combining together we can say that F is proportional to magnitude of Q1 Q2 divided by R square. This is what the expression for Coulomb's law. So when we try to write down this expression in terms of equation, in equation form, we have to put a constant k Q1 Q2 divided by R square. This is the Coulomb's law equation. So the law states that the force of attraction or force of repulsion is directly proportional to the magnitude of the product of the charges and inversely proportional to the square of distance. One important point you have to note here. What is the direction of the force? The force will act along the line joining the two charges. That is very important. So here also you can have the force, here also you can have the force. And this can be expressed as, here this is second charge, this is first charge. Q1 exerts force on Q2 and the direction of the force can be written as F21 vector. So this F21 vector is nothing but the force acting on the charged particle Q2 by Q1. At the same time, how will you write this one? The force is exerted by Q2 on Q1 and this can be written as F12 vector, which means force is acting on Q1 charge by Q2 charge. See, what is the direction here? The direction is represented by the unit vector. The unit vector is R12 cap here and here R21 cap. So in which direction the force is acting? Here R12 cap means the force is originated from Q1 and is along this way. Similarly, R21 cap is nothing but force is originated from Q2 and is acting along this way. And in fact, R12 cap is nothing but minus R21 cap. Therefore, you can say that F21 vector is equal to minus of F12 vector. So the forces are equal and opposite in nature. Now let's talk about the constant. Here the constant of proportionality is written as 1 divided by 4 pi epsilon. What is epsilon? Epsilon is nothing but permittivity of the medium. Permittivity. What is permittivity? Permittivity is the character of the medium. How much force is allowed by the medium? That is what your permittivity. In fact, this permittivity can be written as epsilon is equal to epsilon naught epsilon r. What is epsilon naught? Epsilon naught is the permittivity in free space or vacuum. Epsilon r is nothing but relative permittivity, which is epsilon divided by epsilon naught. In fact, epsilon r is equal to 1 for vacuum or free space. For other dielectric medium, epsilon r is greater than 1. This is what our important point should be noted here. Another important point. So what we have written here, F is equal to constant 1 divided by 4 pi epsilon for medium, Q1, Q2 divided by R square, right, in scalar form. See, force here is related to three quantities mainly, charges Q1 and Q2 and finally distance. For instance, when we have Q1 is equal to 2Q2, okay. So when the first charge is doubled, what will happen? The force will become F prime is equal to 2 times the original force. Similarly, Q2 is 2Q1. When we have two charges, both are doubled. See, Q1 prime is okay. Initially what we have seen here, Q1 is equal to 2Q2 means what happens here? Or simply you can say that in other way, Q1 prime is, instead of writing this, Q1 prime is 2Q1, the new force becomes 2F, and Q2 prime is also 2Q2. When we multiply these two charges, the new force will be 4 times F. This is the impact of the charges when we double or triple like that. At the same time, when the distance r prime is, for example, 2r, what happens to the force? The new force will be, since it is inversely proposed square of distance, and this becomes, what will happen? This becomes 1/4 of the original force, because 2 square is 4, 1 by 4. When you make the distance half, r by 2, then automatically the new force will be 4 times the original force. This is the impact factors, the factors affecting the force, charges as well as distance. This is very important point you have to note. And I will define what is 1 coulomb on the basis of the Coulomb's law. What is 1 coulomb? In fact, we will define the same thing in electricity, but here we will define on the basis of the electrostatic force between the charges. For that, when we assume this condition, when Q1 is equal to Q2 is equal to 1, say unity, and distance between the charges also equal to 1 meter, then automatically the force becomes 1 divided by 4 pi epsilon 0. When we have the system in air medium or free space, and you will get 1 into 1 divided by 1 square, and ultimately you are getting 1 divided by 4 pi epsilon 0. So the value of epsilon 0 is a familiar one. It is experimental value 8.85 into 10 to the power of minus 12. And when you substitute this, you will get 9 into 10 to the power of 9 Newton. So when the force of attraction or repulsion between the two charges, which are unity, separated in free space at a unit distance, if the force between the two unit charges is 9 into 10 to the power of 9 Newton, then the charge kept in that system will be equal to 1 coulomb. That is the definition for 1 coulomb, is very, very important definition for us. So this is very important concept. Coulomb's law is very important concept, and how the forces can be varied by changing the charges as well as by changing the distance. And also very important point I will tell you how to find out the unit of epsilon. That is our another question. We know that F is equal to 1 divided by 4 pi epsilon q1 q2 divided by r square, right? So I want to find out the unit for epsilon. So I can get here q1 q2 divided by fr square. This is the expression for epsilon, and substitute the units coulomb into coulomb. Coulomb is the unit of charge divided by Newton into meter square. So bringing the denominator to numerator, you will get coulomb square Newton to the power of minus 1, Newton inverse, and meter to the power of minus 2. So this is the unit for permittivity, and unit for 1 by 4 pi epsilon, just take reciprocal, that is Newton meter square coulomb to the power of minus 2. And even you can substitute the dimensions for also, I will tell you later. So this session is very important session for you, and you have learned what is Coulomb's law, what is a statement, and what is a mathematical expression, and what is the role of the constant, and also you have studied about how the forces, how the electrostatic force can be varied by changing the values of the charges and distance. So keep in touch and watch all the videos I will post hereafter regularly, and you can follow all the videos which will be very useful for your board examination. So please subscribe the channel and share your friends. Thank you so much.